G'day. Another trig function for us to integrate. This time, the cosine of 3x plus pi. Remembering, of course, that pi is just a number. It's not a function, there's nothing strange about it, it's just a number. And we would know that if we just integrate the cosine, we get sine, because the derivative of sine is cosine. So we expect a very simple structure for our answer. It's complicated because this is a function in its own right. So we have cosine of a function. Now, again, we have two ways of handling this. We can substitute u, or some other pronumeral, for 3x plus pi, and let it all work out that way. Or we can look for the pattern. Now, the pattern would be, you will get used to this, but you can scratch this very quickly on the side of a page. If the derivative of sine f of x is cos f of x times the derivative. I hope that's big enough for you to read. It's meant to just be something that you could scribble in a test as well, if you haven't remembered it. So the derivative of sine is cos, and then being a chain rule, derivative of f is f dash x. Multiply both sides by dx. Take the integral of both sides, which means this disappears because the integral of the derivative, they're inverse functions, so they get rid of each other. And this is the pattern we're looking for. So we're looking for cosine of a function, which we have, times the derivative of the function. Well, I'll write it out again. We've got cos 3x plus pi dx. There's our function, or cos of the function, and we want the derivative of the function at the front. Now the derivative of 3x plus pi is 3. That's what we want there to match that pattern exactly. If we put a 3 there, you know now that we need a third out the front, because a third of 3 is 1, and multiplying by 1 will not change the value of the function. If you've been watching my other videos, this is something I say all the time. Consequently, our integral will be 1/3, and the integral of this, now that it matches this pattern exactly, will be sine of whatever that function was. Oh, sorry. Whoa, I'm getting lost here. Plus c. And a third of that is the same as dividing that by 3, which I think is a nicer way to write it. But you're welcome to leave a third out the front if you wish. Now, I think we will substitute as well. So, same integral, cos 3x plus pi dx equals, we let u equal 3x plus pi, which means that du dx equals 3, which means that du is 3 dx. So we get cos of this, and now we have a substitution for that, that's worth u. So we have cos u, and we're going to replace dx. So we'll go one step further here. If we divide both sides by 3, we get du on 3 equals dx. So it means that this dx can be replaced with du on 3. Now, of course, this third we can move out the front. Which you can see, the integral of cos u is just sine u. And actually I realised I've run out of room, so I'm going to replace it here. U was 3x plus pi, so I can replace that with 3x plus pi. I'm sorry for squeezing that in. Let's move the plus c over. And you can see we have the same result, sine 3x plus pi over 3 plus c. I think you're getting to understand my refrain now that there are often 2 or 3 methods of solving something, and it's good to become versatile with both, be aware of both, and practice both. Each has their respective merits. So, thank you for watching.